Namaskar. In this video, I will explain corrosion, rust, mechanism of rust, and methods used for the prevention of rust. It is very interesting topic, so let us study corrosion. Corrosion is the deterioration of the metals when the metals are exposed to atmospheric conditions like temperature, pressure, presence of water, carbon dioxide, oxygen, etc. And in case of iron, this corrosion is called rust. So, rust is nothing but corrosion in case of iron. So let us start the mechanism of rusting of iron. And as I have explained, during the rainy days, there are so many acids present in water like H2SO4, HCl, HNO3, etc. And all these acids give H positive ions, and hence in rainwater H positive ions are present, and H positive ions are the ions responsible for the rusting of iron. First of all, oxidation of iron takes place. First of all, oxidation of iron takes place. Solid iron undergo oxidation and it becomes iron 2 positive, aqueous, plus 2 electrons. This is the oxidation half reaction. And then these H positive ions present in rainwater, they gain these electrons and ultimately water is produced. And that reaction is reduction reaction. A reduction of H positive ions. Suppose we have two H positive ions, they undergo reduction by gaining 2 electrons and 2 H atoms are formed. These 2 H atoms combine with oxygen present in the atmosphere and H2O is formed. You can say this is the second reaction. In the first reaction, iron undergo oxidation and it becomes iron 2 positive. And in second reaction, H positive ions absorb these electrons, gain these electrons, and ultimately water is formed. And now, from these two reactions, what are the products formed? Iron 2 positive and water. Then these two products of the reactions, they react with each other. Like iron 2 positive 2 moles and 2 moles of water and half mole of oxygen, they will combine and there will be Fe2O3, 2 iron Fe2O3, 2 oxygen from water and 1 oxygen from this, and we get 3 oxygen. And what is the remaining? There are 4 H positive ions. 4 H positive ions. You can see that the positive charge is also balanced. 2 positive multiplied by 2, 4 positive, and 1 positive charge multiplied by 4, 4 positive. Charge is balanced and all the other atoms are also balanced. So this is the reaction between iron 2 positive and water, and ultimately this Fe2O3 formed combines with X molecules of water and Fe2O3 XH2O is formed, and this is nothing but rust. Fe2O3 and unknown molecules of water. This is the chemical formula of rust, and in this way rust is formed. In this way rust takes place. So there are so many methods by which we can prevent the formation of rusting. Let us study those preventive methods. Very simple and appropriate method is barrier protection. Barrier protection. For example, in rainy days, if we want that our object should not be in contact with water, then we can apply grease or oil or any paint over the surface of iron object. So these layers will act as a barrier between the iron object and the atmospheric conditions like water, carbon dioxide, oxygen, H positive ions, etc. And iron can be protected from the rust. Second method is sacrificial protection. Sacrificial protection. And as the name implies, there will be some sacrification. There will be some sacrifice. For example, if we want to protect iron, then the other metal in place of iron will give the sacrifice, and hence iron can be protected. For example, if we have this iron object and we want to protect this object from the rusting of iron, then we will apply a thin layer of paint, oil or grease. Then it can be protected according to barrier protection. But in sacrificial protection, we will apply coating of zinc. We will apply coating of zinc. If anything from these will be applied, then that will be barrier protection. This will also create barrier, but this is the new method. When coating of zinc is applied, then zinc will sacrifice itself. It will undergo oxidation and iron object can be protected. And coating of zinc over the surface of iron is called galvanization. It is called galvanization, and this is the sacrificial protection. Number 3 is electrical protection. Electrical protection. And it is again very similar topic that if iron is coated with zinc, then that will be sacrificial protection. But if iron object is connected to zinc, then that will be electrical protection. For example, if we have underground water pipes, then coating of zinc is not possible. Then what we will do, we will connect this iron object and connect it to a container having solid zinc. This will undergo oxidation and 2 electrons are ejected. These 2 electrons come from zinc container to iron pipes. Because the reduction potential of zinc is lesser than the reduction potential of iron, then comparatively zinc will lose electrons and those electrons will come from this container to iron object. And as electrons are moving from this container to iron object, there will be some electric current set up in this wire. That's why this is called electrical protection. Otherwise, in sacrificial protection, zinc is used, and in this case also zinc is used, but the methodology is different. So this method is called the electrical protection to prevent the iron from rusting. And fourth method is by the use of anti-rust solutions. By the use of anti-rust solutions. And we know that alkaline solutions of phosphates and alkaline solutions of chromates, they have qualities to prevent iron from rusting. That's why they are called anti-rust solutions. They are against the possibility of rust. So such solutions are used as a coating material for iron object and they prevent iron from rusting. But in today's atmosphere, when electrical protection and sacrificial protection are little bit outdated, now what we do, we dip iron in concentrated HNO3. We dip iron in concentrated HNO3, and after some times this iron loses all its properties, like to undergo oxidation, to react with any other atmospheric conditions. In this way, this iron becomes passive iron, and now this passive iron is not suitable for any reaction. So this iron, you can say, is automatically get protected from the rust. So this method is also you can say in trend these days, but as far as the syllabus is concerned, these are 4 methods. They are little bit interconnected to each other, but a thin hair-like difference is there in all the methods that I have explained to you. So I think it will be now clear that what is rust, what is corrosion, what are the methods used to prevent iron from the rust. Thank you very much.